So the basics of probability are now covered in the previous parts. It's time to start talking about independent events. Independent is a word you'll have heard many times before. So for example, if someone is investigating something as like a lawyer, you want them to be independent. That might mean, for example, the lawyer isn't the brother of somebody involved. What does independent mean in terms of probability? Well, let's imagine that I toss a coin and I roll a die. Then let's look at a pair of events that I use an umbrella and that it rains. So think about these two pairs of events and think about what I could mean when I say they are independent events in probability. Well, the top pair are independent. The bottom pair are not independent. I'll give you another example of a pair that are not independent. I'm going to roll one die. Okay. Now in this one roll, the probability I get a 3 and the probability I get a 5. They are not independent. So what does independent mean? Okay. Think about why this one here is not independent. What was the impact of this, the rain, on the umbrella situation? Well, if you've watched the videos on probability, you'll have heard the word causation. In this situation, it's likely that the rain causes a change in the probability of the umbrella. So for example, the probability of the umbrella might be 0.1 if it's due to not rain, and if it's due to rain that day, the umbrella might be 0.7. Now I say due to rain, it could be that it's actually raining because you could find an umbrella and use it. But there's a cause in the relationship there. The rain impacts the umbrella. What about the single die? Well, these two events are linked. Because they are linked, we have an issue. In that one of them means if this happens, this can't happen. So there is again a cause in the relationship. And the reason these two are independent is, well, what happens when I toss my coin makes no difference to what happens when I roll my dice. So, the outcome of one event does not change the probability of the other. Quite a crucial idea here. So why are we talking about independent events? And what we're going to call the AND rule. So tossing a coin and rolling a dice. Umbrella and rain. Well, in lots of situations in life, we're going to have to talk about multiple events. The probability of a complicated bank loan failing used to be thought to be independent as an event from another bank loan failing. Now, what happened in 2008 in the UK and the rest of the world was, we realised that these events were not truly independent and that this had an impact on this. And understanding independent events was part of the reason that we had such a big financial crash, which has changed your life wherever you live. So independent events are really important. So let's go back now before we move on to this bit and look at this possibility space diagram from part 4. And we'll use this for our independent events because we had a coin and we had a die. So the probability of a heads being tossed and a 1 on the die is equal to what? Well, here is heads and 1. If I look along here and down here, there are no other heads and 1s. So it's 1 out of something. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So the probability of a head and a 1 was 1/12. Now bear in mind the probability of a heads is a half and the probability of a 1 on a die is 1/6. Can you see some kind of link here? Can you spot a relationship that we can use? Okay, 1/2 times 1/6 is 1/12. The probability of a heads times by the probability of a 1 was equal to the probability of a heads and a 1. Because, and this is where what we've just explained is crucial, they are independent. So we can see here, for a pair of independent events, the probability of A times the probability of B equals the probability of A and B. We could use that to then say the probability of A and B and C, if these 3 events are all independent, is this. Before we saw this. Back earlier on in part 3. So now we have a pair of rules. One that works when they are independent, and the other that worked when the events were mutually exclusive. Independent was don't affect each other, and mutually exclusive is can't happen at the same time. So using this new rule about independence, if the probability it rains is 0.2 and the probability that Liverpool win is 0.9, the probability it rains and Liverpool win is those two probabilities multiplied together. If they are independent. So a crucial rule here that we've got that's come out of our possibility space diagram. We've now got a rule that we would know as the AND rule, and we previously had one we would know as the OR rule. The OR rule and the AND rule. And they're going to be your fundamental building blocks for calculating the probability. And over the next 4 parts, we're going to develop these to look at pairs of situations that happen that are independent of each other.